Hi, I'm Peter Manos, Director of Research for Electric Power and Smart Grids here at ARC Advisory Group, and want to welcome you virtually as well as our attendees at our ARC Advisory Group Annual Forum, our 29th Annual Forum. And I have with me Peter Rice from Siemens Energy and Damien Beauchamp from 8 Rivers. Thank you for being here, guys. I'm here to talk about carbon capture and storage technologies. So start from the top. What are carbon capture technologies and how do they work to reduce emissions?
Well, thanks for having us, Peter. It's been a very exciting conference that ARC sponsored this week, and glad to be a part of it. So for Siemens Energy, we're playing in all of the above. So looking at not only the renewable spectrum, conventional, the nuclear, but in the area of carbon capture, the spectrum, color spectrum for hydrogens, we play in all of the above. And in the case of carbon capture, what it means for us are basically direct combustion, which we have a strategic partnership with 8 Rivers in the overall process, and we're developing the turbo machinery equipment for that. So we're heavily invested into that business. We're in post-combustion capture, and that's also got a very broad spectrum. So in that, we're looking at partners, and so it's all of the above.
Well, typically in carbon capture, you'll remove the CO2 from the tailpipe, from the effluent. What 8 Rivers and Siemens Energy have partnered to do that's different is we're actually producing pure CO2 out of the tailpipe, and we're using CO2 to spin the turbine. So by inherently capturing the CO2 and not using an adsorbent on the back end, we inherently make it cheaper. But while also making it cheaper, we make it more energy efficient as well. Because whenever you use an adsorbent, you need to use energy to then release the CO2 from that adsorbent. Where when you just burn cleanly with pure oxygen, like we're doing in the supercritical CO2 power cycle, we inherently capture and produce CO2 at 100% purity using no adsorbent.
And part of that cycle, I think for me on the journey with 8 Rivers, it's been a learning experience because in the power business for Siemens Energy, we tend to look at things as the levelized cost of electricity. And so as we open up that spectrum with all of the constituents that are offtake from that closed loop cycle, everything can be monetized. And so from a business perspective, we've learned to take advantage of all of the constituents from that process.
Interesting. So what are the challenges and opportunities when it comes to implementing carbon capture and storage at scale, at large scale?
I think, one of the biggest challenges today is building things in the United States. We're not really able to build large infrastructure projects these days. It's typically, we'll do power plants, but the last refinery was built in 1972. So we do need some level of permitting reform. I would say that's been the biggest challenge, because with these power plants, you not only have the interconnection, which is currently a huge problem across the US due to the number of renewable-based interconnections that are happening, but you also need a CO2 pipeline. And that CO2 pipeline either needs to run to an oil field for enhanced oil recovery, or to a class 6 well, which does pure sequestration of the CO2. And in order to get that pipeline built, you need permits. And so you need cooperation of local, state, and federal governments to get that done. And I would say that is the single most significant impediment today. The technology has been developed over the past 20 years, but in order to implement that technology, you need to be able to sink that CO2 somewhere.
And I'd echo that too, we track every well permit, every pipeline, every node coming off of that, because in the case of carbon capture, it may not be a technology for every power plant or emitter application. So proximity to those pipelines, and they're in the permitting time. And that's, for a planning cycle, we found that to have a very long runway to reach that. And I might add the same challenge we're running into for scale hydrogen. And in that case, we have the broadest range of conventional turbines that can run on hydrogen.
Or in a mix of natural gas and hydrogen as well, it seems.
Or flexible fuels. And the same we're finding there is the ability for large-scale, continuous hydrogen. So it affects all areas of the spectrum.
Makes sense. So how do different countries' policies and regulations impact the implementation of carbon capture?
So obviously, if there's carbon tax or credits, tax offsets, incentives, those obviously help the economic case for carbon capture. What's different about what 8 Rivers and Siemens Energy are designing is that we can deploy these systems without any tax credits. So right now in the US, there's 5,700 miles of CO2 pipeline. And CO2 is used in tremendous volume for what's called enhanced oil recovery. And in enhanced oil recovery, the CO2 has an inherent value. It's 40% of WTI oil price. And so if you think about a typical power plant just consumes fuel, produces electrons. What we're developing, and it consumes fuel, produces electrons, then produces CO2, which can produce more oil. So there's a greater economic incentive. It's not just about go sequester the CO2 somewhere. Now, if you're just purely sequestering the CO2, you obviously have no additional revenue stream coming from the CO2 for sequestration. And in that instance, you do need government support in policy support, tax incentives, some kind of price on carbon.
And what we're seeing globally is not only a carrot like currently we've been enjoying here in the US on incentive-based deployment, but also areas where there's carbon taxes or a stick involved. What's the common denominator is CO2 emissions and the desire for governments, regions to do something with that, whether it's capturing it or utilizing that as an industrial gas.
So what role do international agreements and collaborations play in advancing carbon capture technologies and climate policies?
So following some of the recent cycle of international conferences and things, I think there continues to be a very strong desire to solve the problem. And what we're finding is that many international companies are reaching across borders. So currently for some of our first-of-a-kind deployment of technologies, we're finding that international players may wish to participate in a country installation in one area, learning the technology, gaining confidence, everything through the FEED studies and onward, and then to take that for deployment at some point in their home country, irrespective of what the laws may be driving or incentivizing.
So it's almost as if the global supply chain and relationships on a B2B level are informing potential value chains that there could be opportunities even when ostensibly a certain country doesn't seem like a great candidate. The players, the asset owner operators in that value chain might still be doing things to move it forward.
You're exactly right, Peter. And for that, deployment of capital, that's common. It many cases doesn't know borders, and we think that we have some very innovative and very good solutions that can be offered, and that sees no borders.
Fantastic. And is 8 Rivers involved both domestically and outside the U.S.?
Yeah. So along the lines of the question you just asked, I think what becomes interesting is when you look at things like CBAM in Europe. So this is where there's a border adjustment based on the carbon intensity.
The carbon border adjustment mechanism.
That's right. And we're developing also an ammonia project in the Gulf Coast of Port Arthur, Texas, to produce blue ammonia, so low CI ammonia. And what we see is there's advantages on the policy side in the US with 45Q or taking that CO2 to even EOR. But then there's also advantages on the European side for the import because the CI actually lowers, if you will, the tariff for bringing that ammonia in. And so there's a bigger incentive on the buyer side, and there's an incentive on the producer-seller side. And that makes a very strong economic argument. At the same time, the leader in kind of looking for this type of import of low carbon fuel has been Japan over the past few decades, and South Korea has joined as well. And so there's certainly a movement around it and international support.
Excellent. Anything else on that, Peter?
And in addition, the offtake of what we're driving from both the combustion and blue hydrogen projects that Damien outlined, those have international markets. And markets drive progress, and progress drives interest.
Excellent. So how might geopolitical tensions and economic factors impact how things proceed with carbon capture and climate change technologies?
So domestically in the U.S., one of the advantages that Rivers has enjoyed has been cross-aisle support. So we're a clean energy technology that utilizes fossil fuel. So we've changed the way that we burn the fossil fuel, and that impacts the emissions and the ultimate environmental outcomes. And so both sides support because one, we're consuming fossil fuel in a cleaner way. We're producing the commodities that the world wants today, whether that's hydrogen or electricity, but then we're also producing another valuable commodity in the form of CO2. And that can be used to increase the productivity of oil reservoirs to produce more fuel domestically. So that's been helpful. Now, obviously, things like the Paris Climate Accord have been certainly helpful because it's kind of forced everybody to look at more innovative and creative ways to produce electricity. And I don't think that, that clean and affordable need to be two separate things. I don't think that clean, affordable, and reliable need to be separate things. They can all be one thing. You can achieve affordability, reliability, and clean energy in one system, but what it takes is a force to cause that change to occur. So people don't really like change, right? If you're kind of in a rut, you're going to stay in that rut unless somebody pushes you out of it and forces you to start to, create new paths and things like this. And I think that's what a lot of the international cooperation has done, is really spurred innovation. It's definitely a catalyst. Yeah.
The other is we need to look at global energy demand. There are still a lot of nations in the world that don't have sufficient energy, which a lot of that often tracks with clean water and just basic things that we take for granted from societal. And those all need to be brought up. The same goes for the demand for power. I mean, we're going through a huge demand. Some would speculate maybe doubling our power output, say for hyperscale data centers and the sort. And so the narrative used to be that, well, we could develop conventional power. You can have that nearly now, and then we'll wait and see how some of the clean energy technologies start to mature. I'm of the opinion you can have both, and that we can do both now, and that even the cost of that, there's a balance. And I know in my case, I've had to learn to look at all of the entire business proposition and not just providing electricity.
And the life cycle cost.
Exactly.
Well, thank you so much, Peter and Damian. This was fascinating. I want to thank our listeners and on behalf of Siemens Energy, 8 Rivers, and ARC Advisory Group, thank you for joining us today.